Good evening, everyone. On behalf of the Royal College Computer Society and the Old Royalist Engineering Professionals Association, I warmly welcome you all to TesserX Workshop Session 1, an Axis 2025 initiative. To officially begin today's session, I'd now like to warmly invite Sushana Iyer, Secretary of Royal College Computer Society, to deliver the welcome speech. Over to you, Iyer.
Good evening, everyone. It's a pleasure to welcome you all to the first workshop of TesserX, an initiative under Axis 2025 and one of the first large-scale school-level ideathons in Sri Lanka, brought to life by the Royal College Computer Society with the collaboration of our Royalist Engineering Professionals Association. TesserX continues to drive student innovation and technical growth. More than just a competition, TesserX is a hands-on platform designed to help you transform ideas into impactful solutions with mentorship, guidance, practical and learning at every step. With the registration nearing its end and interest is still growing, we all of you to get involved if you haven't already. Today's session focuses on a fundamental tool in any developer's toolkit, version control. Whether you are working alone or in a team, version control plays a key role in collaborating effectively, managing code, collaborating effectively, and maintaining the integrity of your project as it grows. We are honored to have Mr. Sandil Ranasinghe, Senior Software Engineer at Haymilo AI, leading today's session. With his background in both software engineering and artificial intelligence, Mr. Ranasinghe brings real-world experience and valuable insights that will help you understand not just how to use version control tools like Git, but why they are critical in modern development workflows. This is a core skill that will serve you well, but not only during TesserX, but also in future tech journey you pursue. With that, I wish you all an insightful and engaging session. Let's keep learning, building, and pushing boundaries together. Thank you.
Thank you to Shanaya for that inspiring welcome. We now move to the highlight of the evening. It is our great pleasure to welcome Mr. Sadil Ranasinghe, a senior software engineer at Haymilo AI, who will be conducting today's workshop on version control. Sir, over to you.
Uh, Give me just a moment to share my screen. Yeah, can I just clarify that you can see this?
Yes, sir.
Okay, wonderful. So today we will be talking about version control with Git. So when you are doing your coding projects, developing some sort of application software, you will definitely need to use version control. So today we will see why we need version control, what version control is, and then we will look at some examples of how to use Git, which is the most popular version control software in the world. And we will also look at some practical examples. So first, what is a coding project? So a coding project is not like a homework assignment or an essay. You don't just write it in one file. A coding project typically has many files and folders having different sorts of code. Maybe there might be images, maybe there are Python files, maybe there are HTML, CSS, and JavaScript files. I think you might have heard of those if you did IT subject in your O levels, and I think so there can be many different kinds of files and folders that make up an application software. If you have played games, for example, and you have opened a game folder, you see there are lots of files like .dll files, asset files, music files. So all of those many files, sometimes hundreds or thousands of files, are made into simple application software. So there might be many people working on that application, and there might be changes every day. There might be new versions that are being made every day. So that kind of a project is what a coding project looks like in reality. So some examples I have mentioned: a website built using HTML, CSS, and JavaScript. So maybe you will have HTML files for every single page in that website, and maybe some JavaScript files that can be run for certain pages, and some CSS files to add style and make the website look nice. Or maybe there is a Python program that analyzes weather data. So maybe you need to store some constants in a JSON file there, and you need one Python file to define all your functions and another one to run your program. Otherwise, it becomes a mess. Or mobile application developed with Flutter. Again, there are many different files in this coding project. So how do we manage these files, especially when you are making lots of changes, you have versions and many people are collaborating? Actually, before that, I think I can show you what one project looks like. So this is something I have been working on with a few friends. So here you can see there are many different things that are being worked on. And if you see here, there are different people who are contributing to this, and there are different changes that are being done by people, and all of these are many files that we have to keep track of, that we have to uh, share with each other, and everyone has to be able to see those changes also. So it's a very complicated endeavor. If you think about it, it's kind of like a much more complicated version of Google Docs. The difference being Google Docs requires to be you to be online, but here you can be offline and do your work and then share it. So why do we need version control? What if we try to do all of this without version control? So here are some common problems you will run into. So for example, maybe you write some code in a file and then you decide, okay, this is not very good, I will change this. But your friend is working with a different version. So maybe you will decide to name it version 2, and then you make a version 3, but that doesn't work. So you don't want to delete version 2, you name that version 3, and so on. At the end of the day, you will end up with like a dozen files, dozen copies of the same file with changes. And then the other thing is, if you decide to just keep making changes in the same file and eventually your code breaks, you don't have an easy way to roll back down to the previous version. And then you have difficulty tracking what changed when, especially when you and maybe 3 4 friends are working on a project. For example, maybe one person makes one change and puts it somewhere, and then someone else was already working on that same file and he also puts a different change and saves that file. Then the first person's changes are lost and again overwritten changes. So there are many problems like this when you work without version control. So then what is version control? It is a system that manages changes to files and documents over time. And you can track modifications, compare different versions, and easily revert to previous states. So if I show this particular project I have been working on, uh, each of these nodes is a change made by someone. So here I have changed one single file. And here I have added a bunch of files. And here someone else has also added a bunch of files and changed some files too. And you can see sometimes there are two tracks. That means two people are parallelly working and merging their changes. So like this, version control allows you to keep track of all of these changes. So even if this change was made last year, I can see what exactly happened in that change. And if something breaks, I can go back to a previous version very easily. So then what is JIT? JIT is a software. JIT is not the general IT paper that you are writing for A-levels. JIT is a software that does version control. So it's a distributed version control system, and it allows you to do things like tracking changes, reverting to previous versions, collaborating with others, that means working with many people, creating branches. So we look at what creating branches is, merging changes and working offline. So if you think about it, I can do whatever I want offline, and then it will allow me to decide what work I want to share with the other people and commit as a change. So then we will look at this later also, but just to mention this now, GitHub is a cloud-based platform for hosting Git repositories. So basically, if you have a project on your computer and you are using Git to track changes as Git as a version control there, then what GitHub does is, in addition to having this Git project on your computer, you can have it on the GitHub cloud, and you can sync the version control tracking between your computer and the cloud. So now if you want 4 different friends who are in different places to work on this project, they can also sync with the GitHub, and every time one of you pushes or pulls changes, all of the others can also view those changes. And the version control can manage all of the changes by itself. So therefore, it makes collaboration easier between multiple people. And there are tools like pull request, issue tracking, etc., which we will discuss later on. So to summarize, GitHub provides a remote, that is a cloud storage for Git repositories, and there are some features that make it easy to collaborate. And there are also some other tools like CI/CD workflows. Again, we will look at what those are later. So next, when working with a Git project and you have a Git local and a GitHub version of that project, so typically we call a project a repository. So a repository is your project containing all your files and all your version control and all your changes, historical and otherwise. So when you're working with a GitHub project, you will typically have a copy of your repository locally. That is the local copy of the GitHub project. And there will be a remote. Remote means on the GitHub cloud, there will be a copy of the repository files. And inside your local, so there will be the formal Git repository that will be synchronized with this external remote repository. So remote is the one on the cloud. This is the local one. And then the working directory, sorry. And then the working directory is basically the folder where you are working. So this is VS Code. I'm not sure if you have seen an IDE before. So maybe I will just show something on my folder. So this is the folder that has all my files. So this folder is my working directory. And there is a temporary area called a staging area where I can add or remove files to Git. So, sorry. So here if you see, I have made, these are all changes I have made to files locally. So all of these files are here in my folder, but they are not there in the local Git repository. That means Git is not tracking them. Git does not know. So whenever let's say I create a new file or I change a file, Git doesn't know anything about that file yet. So what I can do is I can add these to the staging area. So the staging area is a temporary area where I can, sort of like a line where I can add files that I want Git to track. And then let's say I have added some files and I now want to move those to be tracked by the JIT version control. So then what do? I will commit those. So commit means from the staging area, we move it into the local repository. That means JIT is permanently tracking those file changes. So again, we will make a new repository later and look at how we do this. But what happens is I type some commit message and I press commit, and then it will make another dot here saying, okay, this file has been added at this point of time. So like all of these dots, with each of these dots show some change, some files added, files change. So like that, another one will be added and JIT will keep track of that. And if I want, I can go back to one of these versions. I can look who made these changes, or I can merge different changes. So you can do anything once it is being tracked. And so far when you commit, it's still on the local repository. So local repository means on your computer only. So there you have the git push and pull commands. Git push pushes all the it essentially synchronizes the remote repository, that is the GitHub repository, with whatever is on your computer. So the newest changes on your computer are pushed from your computer to GitHub. Pull means you pull the newest changes from the GitHub repository to your computer. So let's say maybe there are a few people working on a project and your friend, he makes some change, he commits it and he pushes it to the GitHub repository. So now that change is there on his computer and it's there on GitHub, but it's not there on your computer. So then you do git pull and it will pull the newest changes to your computer's repository, so your local repository. And if you want to undo a commit, you can use the git reset command. So this final dot, that is the last commit that was made, is called the head in git. So what git reset does is it will move this head backwards. So if you feel like the last few changes broke your code, maybe you can just go back to the last place where your project was working. So that is what git reset does. And then git add and git restore are for adding and removing files from the temporary staging area. So that's how the basic git workflow works. There are some more advanced features like merging and rebasing, for example, and cherry picking, but we won't go into too much detail about that. We'll just cover the basics that you need to get started on a Git project. So these are the Git and GitHub documentation links. So I think we can arrange to have this shared. I'll just put this in the chat also. So here, this is the basic Git documentation. You can find reference, tutorials, everything that you need about Git over here. And for installing Git, if you are using a Linux or a Mac OS, you will generally already have Git available. So, but if you want, you can follow these instructions to install it just in case it's not available. If you are on Windows, take a look at this and see how you can install Git. Typically, these are easier. I think there's a project called Git for Windows which comes with a Git bash and everything. So just follow these instructions, open this and download Git and install it if you're using Windows. If you're using Mac or Linux, you probably already have it, but if not, it's very easy. You just have to install whatever tools that you need. And then you have the GitHub documentation. So again, anything related to GitHub you can find there. In particular, my bad, I left an extra space there. So this page in particular might be helpful for starting out. It shows you how to make a new repository and everything. So when you have some time, go to github.com. So I am already signed in, but if you don't have GitHub account, it will ask you to sign up, and you can sign up with Google or whatever, and then you will come to an interface like this. Next. Okay, so come to an interface like this, and there you can make a new repository if you want. So I will make a new repository. Demo. Yes, I think I got that one correct. Let me just check. Yeah. So you just have to give a name. If you want, you can give a description. So here you can select whether a repository is public or private. So public means anyone with the on the internet can see it. Private means only people you share with can see it. And then you can just create a repository. So there are two ways to handle this. So if you want to create a new project, you can follow these commands. Or if you want, if you already have an existing repository somewhere, you can add this. So if you have a local repository, you can add this as the remote repository. So either of those can be done. So we'll quickly take a look at what these commands mean. So these are some commonly used commands that you need. So git init initializes a new git repository locally on your computer. Git status shows the working directory status. So basically here this is the IDE interface, but I mean if I put git status, it should show me something similar. Here it will show me changes that have not been committed but have been staged. So this is the staging area, and these are all files that have not been staged. So if you look at this, these are new files and these are previously existing files that were changed. So you can see that with git status. Git add, what git add does is it adds a file to the staging area for commit. So actually we will make a new repository and we will look at how this works. So, sorry, my bad. Just gonna put this and so I'm going to open this with VS Code, but if you are using a different IDE, or if you want to use your command PowerShell or Bash or ZSH or whatever that you have on your computer, use that, it is fine. So I will initialize a git repository using git init. And typically when you're following the guide, you will see how to somewhere here or here you will find the instructions on how to initialize your GitHub user locally, so that your local Git software knows what GitHub account you're using. So I already have multiple accounts locally. So I will also have to switch it. So you can local configure these locally so that your local Git software knows who you are, and if it needs to commit, if it needs to push and pull with an external repo, knows what credentials, what GitHub account to use. So here I'm going to set my name. So my name, sorry, this is the wrong place, isn't it? My bad. Anyways, the name and the name is what will come here as an author for each commit. So where's that project? And you can add your email. And finally, so typically Git comes with a credential helper, but there are different credential helpers. You can also add yourself if you want. So here, what this does is it lets you figure out what your account is, your GitHub account. Or there are some other cloud solutions also like Bitbucket or GitLab, which also host Git projects. But the most popular is GitHub. So we'll just look at GitHub. Configure again. So, and here you can see these changes that I made. Oh, my bad, I forgot to say. That should be email. And now I have initialized the project. Now I maybe want to create some files. I will make the README file. Hello. Hello. Yes. Git project. So I have made this file called readme.markdown, and you can actually see the instructions on what to do over here. So first you initialize, and so here what they have done is they have just created a file with some name in it. So same thing we just did, and then you add readme.md to the staging area. So we'll see git status. So here there is nothing going on here. No commits yet, no staging area is empty. There is a single untracked file readme.md. So typically using almost all IDEs have some sort of version control UI. So if you like, it is a lot easier to work with this, but I will show you both because you need to know what the commands do. So here, these are untracked changes. So they are the changes in the working directory over here. So changes are here, and now we are going to git add something to the staging area. So 1 second, let me just. So now we will add the readme file. Now it has moved to the staging area. So if I put git status, now I can see there are no untracked files. In the staging area, there is a new file that has been added. And now actually you can see our next instruction here also. We want to commit that. So a commit moves some files or some set of changes into the local repository. So generally when you are working on a feature, say, if you have made a set of changes that make sense, so if I was going to initialize my project, maybe I will, if I had more files that I wanted to add, maybe I will add all of them in one commit. So maybe I want to add another file, say main.py. This will be our main file, and if name equals main, then hello. So maybe I will add that file also into my commit. So now I will commit this, and I will say init repo something. So typically we will again look at commit messages. You want to describe what changes you did here in your commit message. So actually I will show it in the command git commit in this message init repo, and now I have committed. So if I see the status now, again there is nothing on the staging area, no untracked files or untracked changes. You can see this is empty, and here you can see on the local repo there is a single commit. So that commit has the changes that we made. And so now our changes are here in this local repo. Now we need to push them into the remote repo. So if you go here, I will refresh this. You go here, this is still empty. So git branch main. So git branch is typically done to make a new branch. So here branch is already main, so we don't really need to run that. And then git remote add origin, this project's URL. So that URL is here. So what this does is, so initially when I just made the local project, it doesn't, I just wrote git in it. I never told it that there is a GitHub project, remote GitHub repository that is corresponding to that. So I need to tell the local Git software that, okay, for this local repo, there is a remote repo on GitHub. So that I do by adding a remote. So this git remote add, that is what that command does. Sorry. And now I can push this. So typically, the very first time you are pushing a branch into a repository, you will need to tell which branch you are pushing, but afterwards you can just do a git push. So alternatively, this publish branch option also works if you have a id. For now, I will show you the command. See, okay, now we would say, okay, new branch set to track, and now you see earlier it didn't say origin over here. So that means main and origin both have this commit. Actually, if I go to that earlier project I was showing you earlier, okay, this is up to date, but sometimes if your, let me just commit something and show you. Now if you see here, this is the latest head on local. So local has one extra commit, whereas origin's head is behind this commit. So now I will have to push if I want this to be synced. So here I push the changes and those changes should be here now. Refresh this. Now you can see the readme file and the main file, main.py file that I added are on GitHub. And let's say I will add a file from over here. We will name this utils.py. And here I will just add a commit saying, I will add a comment saying any utility functions here. I will just commit this change. Now you see this utils.py is there, but here it's not there yet. So now we will have to do a pull. So actually, I'm not sure if I was going to show you git fetch. There's a command called git fetch. It doesn't actually bring any changes locally, but it keeps up to date what is different between the two repos. So I will first run that. Now, when I run the git fetch, you can see origin is one extra commit ahead. That is the commit that added this utils.py file. But main is still over here in the initial commit. So that means we have to git pull. So I don't know if you can see clearly over here. It shows you one pull needs to come, 0 pushes need to go to the remote repository. So you can easily sync this by pressing this, but for now again I will show you the git command, git pull. So now the utils.py file has come to my local repository from the remote repository. So from here it came here. So that way you can do the basic workflow of adding files, adding a remote, committing, pushing and pulling. I think I forgot to add git pull to this list here. But yeah, I think you can see those commands. All of these are general basic commands, so you need to get familiar with those. And finally, git restore to restore files in working directory. So that means, let's say I add some CD file. And I stage this. Now it is staged, but I don't really want this function. Maybe I want to get rid of this file. So then I can just type git restore. Before that, let me show the git status. So let's remember the git. If you have an IDE open, I recommend VS Code, but if you are using anything else, you can check with those. Here you can just see that this file has been staged, dating commit, and you can restore. And now if I see, I typed that wrong. I'll just do it with this. Now if I check the status, you can see it has gone back to untracked files, which is just files that I know work directly but not tracked by git. So like that, you can easily handle all of that if you have an IDE over here. But just keep in mind what is happening with the jig commands underneath. So for now, I don't need this. I'm just gonna remove this. And I think that covers most of the basic JIT commands. So some small things that we'll go over. Commit messages. So commit message is the message I put when I was making a commit. So initialize repo, init repo, create utils.py. So if you are try to describe what you change you are doing when you add a commit. So that way, this is actually not very well done. But you can see each of these commits explain what was done in that commit. Fix graph error in this particular model. Fix graph header and t value. Implement utility functions. So like that, in your commit message, try to explain, and here are some conventions to follow. Take a look if you are interested. It's not particularly strict if you are working on a small project, but for big projects, it is important. Next, branching in JIT. So what is a branch? A branch means you can branch off of the workflow and parallelly work on a different version of the files. So I show you, this is a branch. So this blue one is the main branch and this is an extra branch. So while people were working on the blue main branch, someone else can work on a different branch on different files. So we'll actually check this out here also. Maybe here I will define a function. And we call main here. And main. And now I will create a new branch. So I'm just going to name this branch one, but typically you want to make a more descriptive name for your branch that explains sort of what your branch's purpose is. So now in this branch, I will do something else. Yeah. So we change name. So now you can see on branch one, main file shows this, but on main file shows this. So parallelly, you are having different versions of the code. So here you can see, and if I add another commit to main, let's say, that was add realistic changes also. So again, you can see here this branch is different. And now if you go here, you can see on main, you have one set of commits. On branch 1, you have a different commit. So this way you can parallelly work on stuff, especially if there are 4 or 5 people working on a project and maybe they want to work on the same files. You can work on branches so that your work doesn't clash with other people's work. So here I use branch, so you can work on new features independently, prevent changes to main code base. So you don't want to break the main code base until your change is in a working condition and it has been tested. So like that, you can use branching. So version control in IDE. So I already showed this to you. IDE is integrated development environment. So something like VS Code, for example, will have a built-in Git integration, and it's a very simple, nice UI, and you can do all of these functions, and you can push, pull, clone, fetch, commit, and then there are some more advanced things you can do. So you can do it easily from the IDE. So again, I think I already showed you what a reset is. Reset means you want to undo a commit. So say, so right now, I want to go back to this commit. So I added the extra function. I decide I don't want that. So then what I can do is I will undo the last commit. And you can see, and maybe if I want, I will unstage this and I will name this foo function. Now I have successfully changed this so that I undid the last commit and added a different commit. So in that you can reset very simply in lines like that. So that's something to keep in mind. So next, projects in GitHub, I think we talked about it already. So when you create a project on GitHub, you are setting up a remote repository. The repository is your project and your files and your Git tracking everything together. So a remote repository which corresponds to your local machine, your local repository, and you will continuously be syncing the local and the remote. So there are some special files. So you already saw the readme.markdown file. So whenever you add a readme.markdown file on GitHub and you go to that project, it will show this readme.markdown file's contents over here as the first thing you see when you come to the repo. And there is another file called gitignore. So the gitignore file allows you to specify files that you want to ignore. So if I add .gitignore and then I add a file called .foo.db. Now you can see this foo.db file is there and the .gitignore file is there. What if I don't want Git to keep track of this foo.database? Maybe it's some useless temporary file that is generated. Then what I can do is I will add star.db. All files that end with db will be ignored by Git. So now you can see it's no longer keeping track of foo.db. So that is the use of the gitignore file, and I will so typically this is the flow where you use GitHub. You clone a project so let's say your friend made a repository. Then to get that onto your local, you will clone that project. So it's just git clone repository URL, and then you get it on local. And if there are new changes, you pull, then you can create a branch to work locally. And then you can commit your changes, keep committing whatever changes you make to that branch. And when you think your branch is ready to be added to the main, you push that branch to GitHub, and if you make commits later, you keep pushing them until, and then when you are ready, you will create a pull request. So a pull request means you want to pull your changes from your branch to the main branch. So let's say I want to pull my changes from branch 1 to main. So then what I can do is I will switch to branch 1. I will publish this branch. And now I go to GitHub. I will make a pull request. So here you can see I want to pull changes from branch 1 to main. So this left side is the one I want to put the changes into, and right side is the one that has my changes. I will create a pull request. So if this is a repository with multiple people, you can ask some people to review your code. So you can see what has changed over here, and then multiple people can review and say, okay, this code is good, or maybe there are some errors, and they can add some comments. So for example, I can see, I will say, great, this is better. And I will add a comment here. And you can see those comments. And then I can merge the pull request. And now, if I were to, I will switch back to main, and I will run a git fetch. Actually, I will run it from here. And now there are sync changes. You can see 2 pulls that need to come. So actually, if I look here, this was my local's head, whereas the head at origin has merged the changes that were already there with branch 1. So typically, so let me just pull this out here. Here you can see now the difference that we made is the work that we did in branch 1 as well as the work that we were doing in the main branch, both is there. So this has replaced this. So that is how you add your changes. So you can create a PR and then you merge that PR, and then it's there in the remote repository. So like I mentioned, a pull request is a way to propose changes and discuss them before merging. So why do you need pull request? You want to review code before merging. So if it's a big project, maybe you will make your changes, and then your friend will look at that to see if you made an error or if the tests are running, etc. Or maybe you can run some tests. You can make sure that everyone is up to date on the code. And maybe if let's say a new person is coming into your projects and he wants to make some changes, he will say, okay, I want these changes. And then you can discuss under that pull request whether these changes are good. So like that, you can make a pull request and do things, and then finally merge your changes. So sometimes, again, we will not look at this in great detail. Sometimes merge conflicts happen when JIT can't automatically merge the changes. So here JIT was able to figure out that earlier main was like this, but now main is going to be like this. So it's a very simple change. I deleted 2 lines and added 1 line. Simple stuff JIT can figure out. But if you make a lot of changes, let's say you take your branch out of, let's say I make a new branch. I will name this branch 2. And in branch 2, I will make some. And I will switch back to main, and again, I will change this same line in main. So now there is something called a merge conflict. Why is this? Because after I broke down the branch, in the branch also I made a change, and in main also I made a change. Both of these after I made the branch. So after this point, I made the change to the same place here and here. So now JIT doesn't know which one to take when you merge both. So that is called a merge conflict, when JIT doesn't know how to automatically merge something. So there you have to manually figure this out and select something. So uh, you how to resolve this. So here common situations are when two people change the same line, or you rename files, or you delete a file that someone else changed, or maybe a line even. How to resolve? You can manually edit to, or you can use tools in IDE. So there are two strategies: merge and rebase. I will not go into detail in them, but basically what I can do is, maybe I will go to this one. I will do a rebase, and here it will say, okay, I want to I have to figure out which change I'm going to pick. I will pick the incoming change, and I will push this. Now you see merge conflict has been resolved and you can merge. So just something to keep in mind. I'm sure you can refer the documentation and figure it out. You can do a rebase, or you can do a merge from main or the relevant branch. So it's very easy to do in IDE. It will highlight and show you everything here, and you can pick what code you want. So next we'll look at GitHub issues. So here you have the pull request tab. Like that, you have a tab for issues. So issues are ways to keep track of problems, discussions, new features, bugs, etc. in a project. So you can keep track of bugs, plan new features. So if you are working with friends, for example, or a team, let's say you have 5 different tasks to do, and you have 3 people working on 3 tasks. Then what you can do is you can add the 5 tasks as issues, and whoever is free can assign an issue for themselves. So here, uh, some demo functions. We So now we have a thing, and can add some labels if you want. And then now you can see there is one issue and there are some labels. You can add those, and if you want, you can mention something. For example, I want to mention a pull request, I can mention it here. So if you are in a pull request already, you can mention an issue here also. see. This was mentioned, and finally you can assign people. So I'm the only one in this repo, so I'll just assign myself, but you can assign people to issues so that you know they are working on that, and you can see here. So that is a very nice feature that GitHub has. And finally, the last thing we'll be taking a look at is GitHub workflows and actions. So GitHub workflows and actions let you automate tasks like testing, building, or deploying your code whenever a specific event occurs in your repository. So a specific event might be when you push your code, or when you merge a PR, or when you create a PR. So something you can do is you can run tests on every PR. So maybe you want to test, you write some test cases to see if your code is always working properly. And whenever someone makes a new pull request, if you have defined an action, what happens is that action will run over here, and you will be able to see an action running here. Unfortunately, I couldn't prepare one. And then the results of that action. So in this case, you will see over here saying, okay, action test cases ran, passed or failed. It will automatically happen. Or maybe if you want, let's say when you merge a pull request, you want to deploy that to a server somewhere. Or maybe you want to send a Slack notification. Or you want to run a linter so that it formats and makes your code look nice. Then there are CI/CD pipelines, scheduled jobs. So many things you can do with GitHub workflows and actions. Again, there is a lot of documentation. You can just take a look at this page if you want. This is very helpful for running tests and checking if formatting and project conventions are followed, and if you are deploying to deploy your code. So I will share this link also here. So, but it's not like absolutely necessary. You can work with Git and GitHub without workflows and actions. I just added it here because it's something that can be useful if you're working on a big project. So yeah, I think with that we have covered a significant. One second. Sorry about that. I think with that we have covered a significant amount about the basics of using Git as a version control software and what GitHub is. So thanks. If you have any questions, I think we can have a few minutes. You can unmute yourself and ask, or you can put any questions on the chat. So I'll just wait a couple of minutes. I think there are no questions right now. So I think if you have any questions later on, you will probably have questions only once you actually start with the coding projects, I guess. So I think the RCCS and the TesserX organizing committee will probably have a way for you to contact resource people. So you can just contact them. I'm sure they will view further announcements later on. So thank you, everyone. I hope all of you learned something useful. Uh, Thanks again for inviting me to the session. Ali, over to you.
Thank you very much, Mr. Sandil, for that engaging and insightful session. We truly appreciate your time and the knowledge you've shared with us today. To formally conclude the evening, I now invite Pulinda Ranaviraya to deliver the vote of thanks.
Good evening, everyone. Hope I'm audible. Uh, right. On behalf of TesserX organizing team, I would like to take a moment to express our sincere gratitude to everyone who made today's session a success. First and foremost, a huge thank you to Mr. Sandil Ranasinghe for taking the time to share his knowledge and expertise on version control with us. I'm pretty sure that your insights and clear explanations have been invaluable in helping our participants build a strong foundation in this crucial area. To all our participants, thank you for your enthusiasm and engagement throughout this session. It's inspiring to see so many bright young minds eager to learn, collaborate, and grow. That's what makes event like this truly meaningful. We would also like to extend our appreciation to the Royal College Computer Society (RCCS) for being a driving force behind the TesserX Ideathon, and to the All Royalist Engineering Professionals Association (OREPA) for their unwavering support and guidance. This partnership between is generations of royals is what empowers us to create opportunities that inspire and empower the next generation of innovators. So once again, thank you all for everyone being part of today's session. Let's keep the spirit of learning and innovation alive as we move forward in this exciting journey. Thank you very much.